So 1-6 inequalities, you have this in your packet, or you could write them out like I did. Okay, so we're going to solve each of these, and we're going to give a solution set and solve on the number line. Okay, so, and we're solving over a particular restricted domain. Okay, so subtract 6 from both sides, get negative 20, divide by negative 4. You're now going to get x is greater than positive 5. Okay, on the number line, it simply looks like this: 0, 1, 2, 3, 4, 5. We're going to have an open circle. Go that way. Okay. Set notation, set of all x such that x is greater than 5. Interval notation, you typically don't have to do both. I might ask for one or the other. You want all the numbers from 5 to infinity. Open parenthesis, because you're not including the 5. You don't include infinity. Okay. Now this one, you've got 3 parts to this inequality. So we want to get the x by itself in the middle. So we'll subtract 9, subtract 9, subtract 9. And 3x in the middle. 5 minus 9 is negative 4. 11 minus 9 is 2. Now divide by 3. We've got negative 4/3 is less than x is less than 2/3. So on the number line, we've got 0, it's called 1, 2, negative 1, negative 2. So 2/3 is about here. Negative 4/3 would be about here. Okay. This one says or equal to. Okay, make sure that I mark that here, which means we include this. We don't include this. With the numbers in between. So there's your solution on a number line. Set notation, set of all x such that x is between negative 4/3. We're going to include the negative 4/3, but don't include the 2/3. Okay, and then set notation would be negative 4/3 to 2/3. So these two things say the same thing. Okay. And we solved over the set of real numbers, so we're going to include everything. Those are all real numbers. This one we got to split into 2. So either 2x plus 9 is already less than 4, or 2x plus 9 is greater than negative 4. Solve both. 2x is less than negative 5, so x is less than negative 2.5. 2x is greater than negative 13, so x is greater than negative 6.5. Solving on a number line. So we've got 0. Okay, these are both negative, so we got 1, 2, 3, 4, 5, 6. Make that a little bit longer. 7, 8. So negative 2.5, which gets me here. Negative 6.5 down here. Greater than negative 6.5, less than negative 2.5. Okay, so the set of all x such that x is between, notice we're not including them, they're open circles. Negative 6.5 and negative 2.5. Okay, the next one, let's split this up. 5x minus 3 is greater than or equal to 3. 5x minus 3 less than or equal to negative 3. 5x greater than or equal to 6. X is greater than or equal to 6 over 5, which is 1.2. And 5x less than or equal to 0. So x less than or equal to 0. So on the number line, we've got x is greater than 1.2. 1, 2. So 1.2 It's going to be about here. We want greater than and less than or equal to 0. So set of all x such that x less than or equal to 0 or x greater than or equal to 1.2. Okay. These were all over the set of real numbers. This one's different over the set of integers. We'll see what happens here. Okay, so we did 3x plus 6 is greater than 22. So you're going to get 3x is greater than 16. X is greater than 16 thirds. Okay, which is about x greater than, that's 5 1/3. And we want integers only. So there's not a great way to write this. 1, 2, 3, 4, 5, 6, 7. Okay. You just want the integers greater than 5 1/3. So 1, 2, 3, 4, 5. There's 5. We're not going to include 5, but we'll include all the integers after this. And then we'll just, it's not a great way to do it, but we're going to show that that pattern continues. And then we would say the set of all x such that x is greater than, we could say greater than or equal to 6, we could say greater than 5, and x is an element of the set of integers. Remember that z represents the set of integers. Okay, and there's not really a way to do this in interval notation. Okay, so in summary, when do we switch the inequality sign? We switch the inequality sign when transforming an absolute value inequality into two inequalities. The first one we leave alone, and for the second one, for second inequality, you switch the symbol, inequality symbol, and the sign of the other side. Okay, I think that's the best we can say. Closed circle when you have an or equals 2. So for instance, when x greater than or equal to 5, or x less than or equal to -2. Okay, so closed circle when you have the or equal to. Open circle when you have just greater than, that so you can see it, x greater than 5, or something like x less than -2. Open circle when you just have or greater than less than. All right.